Well, we are on the air everywhere. The blowtorch of weather. WeatherBrains episode number 517, the pre-show for December 14th, 2015. The year rapidly fading away. And if you're new to this, the actual program starts in about 7 minutes. Just move the little slider on by. But we just thought we'd turn it on early so you could see the foolishness that takes place here. And we do three things. We share boring personal stories, humorous anecdotes, and occasionally say outrageous things. And I'm more of the outrageous thing guy or the boring story guy. I don't do humorous stuff. I'm not funny. Rick is funny. Rick Smith is a funny man.
You know, when you say that, it's impossible to be funny after you tell someone they're funny.
Be funny.
Be funny. Tell a joke.
Were you on the Weather Channel tonight?
Yeah, I did a little thing on the Weather Channel, the whatever it's called, the Weather Underground thing. It was at 6:40 Central Time, talking about social media and weather. Go figure. I don't know why they were asking those questions, but no.
Now, do you do that from the office or from your WeatherBrains corporate headquarters there?
I just did it from the elite WeatherBrains studios here at the spare bedroom of my house. So.
Yes. Internationally, no.
Those are my WeatherBrains studios.
That's right.
Is that a new monitor in the back there, Aubrey?
No, that's my brother's monitor where he works from home.
Okay.
Also from our WeatherBrains headquarters.
It looks nice. All right, this is great. See, I don't have to invite the guests anymore. This is fantastic. Bill is bringing the guests in here. Boy, this is nice. And again, just logistically here, I have to leave extra early because I'm doing the late news, the 11 o'clock Eastern Time news, at an undisclosed location. No, actually, it's at a restaurant. Our Christmas charity ministry, whatever, it's Toys for Tots here, and due to the nature of having to distribute this and administer this, they have to have it finished by like tomorrow. So we wrap up the drive tomorrow, and so this is the marathon. So I'll be leaving a little early, so we'll get the pre-recorded stuff in early, and then one of our fine associates here will carry us to the end. What's interesting, the Marines, the United States Marines, they have been our partner in this thing for years. This year, they are not allowed to wear their uniforms at our appearances. So what does that mean? This is apparently some big order from the top where they can't be seen in uniform on television, which I find interesting. The conspiracy theory guys will love that one. We'll let somebody figure that out. Kevin, can you hear us?
I can. How are you?
Good, man. Looking good.
Thank you.
Kevin always looks good.
Eric, can you hear us?
Eric can hear you. Can you hear me?
Yeah, man.
Yay. I love it when things work.
Occasionally it does. So yeah, Aubrey's got to leave early too. So I'm gonna move the mail segment up like before we get into the guests.
Oh.
And
well, let me pull it out.
Yeah, I was about to say give you some fair warning on that.
Yep.
And, I do want to talk about the National Weather Service in Amarillo.
Oh boy.
Well, this is all people are talking about. They don't want to. They're not. If they tune into the show, they want the hot topic. They want the sexy stuff. So.
You got Eric Rasmussen tonight. What else you want?
Well, yeah, we got some sexy people on the show, but I'm just saying that the weather world is talking about this incident involving a storm spotter, chaser, whatever, in the Weather Service in Amarillo in a Twitter exchange. So, see, nobody wants to say anything. They're afraid they're going to make somebody mad. That's all we do in the show is make people mad.
Kevin will talk about it. Yeah, Kevin will talk about it.
Anything you say is going to make somebody mad these days. I mean,
nobody's watching this show anyway.
Yeah, just us and
20,000 other people.
Yeah, the Weather Enterprise. All right, so we in 2 minutes when I see us hit the television, and Eric and Kevin, just so you guys will know for disclosure here, this is on broadcast television. It's on the .2s in my market, which is on cable. And I kind of have to wait until the bottom of the hour, and once we hit that, we can get the show going. Dr. John is typically here by now. I think he'll show up, and then Nate said he will be here. So Brian Peters is out. He is in Chicago. And other than that, I think we're good to go here. So,
What is
Bill, what are you eating? I'm sorry, Eric, what did you say?
Ice cream. I had a.
I'm just wondering what Bill's eating.
That's the same question I was asking. I mean, there's one guy.
Yeah, I had
chomping noise.
a new crown put on today, so this is the first chance I've had to eat any real food besides soup.
Bill, I think the two of us need to go for a 2-for-1 tope special.
Well, I think we should invite Kevin too.
Yeah.
Well, I wasn't going to hurt his feelings, but I'm just saying that might be a 3-for-1 special. And we're not going to buy the cheap toupee glue, because that cheap stuff is not rated for hurricane force winds. I mean, if you're out in a hurricane, that thing might blow halfway to Cuba. So
we needed some strong toupee glue yesterday around here.
Yeah,
If you get one, you got to go full out and get the John Scala model.
Yeah, I'm telling you, this guy, it can't be his real hair. And I tugged on it in Oklahoma. He allowed me to touch it and pull, see if it would come off. And it's either his real hair or it's some really good toupee glues. So.
I tugged on it in Oklahoma as a show title.
That'll get past the Brian censorship tonight too. That'll be good.
Oh, yeah.
Whoever's in charge of the website, that's the show title.
That's it. Bill, your audio's a tad hot.
Okay. Yeah, my mic was all jacked up, so sorry about that. How about now?
That's
Testing,
much
1, 2,
better.
3. All right.
All right, so we're almost there. We're standing by to stand by. All right. Hello, television viewers. Welcome. Let me get the recorders going here. We're actually going to start almost on time, which is a shocker. Unbelievable, but true. All right. We are recording both channels. And here we go in 5, 4, 3, 2, 1.
Jingle bells, jingle bells.
Oh yeah, all the way.
Jingle all the way.
This is WeatherBrains, episode number 517 for the 14th of December, 2015. Man, the year is just fading so fast. Thank you for taking the time to join us. My name is James Spann, and we are in the process of bringing on a cool show. And let me just say up front, there's going to be a little bit of a difference here. I've got to leave early because I am on location tonight on the television side, so we have plenty of professional hosts here that will carry the show to the end, but we're probably going to do some of the segments you would typically hear near the end of the show closer to the front this time. But it's always good to see Aubrey Urbanowitz, who is the classy act of the group.
You lie, James Spann.
No, you are. I mean, everybody likes you. I've not heard anybody say one bad word about you, which is
that's good.
in this business.
That's good. That's important to be likable.
No, you are liked, loved, and appreciated. So what's happening in the lovely Shenandoah Valley?
Oh, it's gorgeous out here. It's beautiful. It's beautiful. We've tied the record on Friday. We broke the record Saturday. Sunday was nice. I thought we were almost going to tie the record tonight. We've actually been going up since about 3 o'clock this afternoon instead of a cold front that was supposed to come through. So I don't know where that cold front went, but it's not here yet.
So what was your warmest over the weekend there?
70. We forecast 72 on Saturday. We hit 73.
Wow.
So the record was 68. In 1897, that was the record.
Wow.
That was your
Dr. Scala had a record today. Nate had a record, so everybody's setting records today.
Yeah, we're having, apparently Dr. John is trying to join us. We'll see if we can get our technical crew on getting Dr. John and Nate on here. But Rick Smith is here from the National Weather Service in Norman, Oklahoma. Rick was just on the Weather Channel. He is now on WeatherBrains. You are a media guy.
What more could you ask for? It's good to be here. I was out last week, and good good to be back and got lots to talk about.
Yeah, so let's get to the good stuff. And again, we're going to introduce our guest in just a second. All right. So, and here's Kevin. So I'm glad he's on here, and there's Nate. So over the weekend we had a situation where the National Weather Service in Amarillo had a Twitter exchange with a storm spotter. You guys familiar with the story?
Never heard it.
No idea what you're talking about.
What is this Twitter you speak of?
Everybody just hang on. I had a freeze here. What would you say, Nate?
I didn't say anything.
I think Rick
I
did.
don't.
Nate's the only one that wanted to talk about it, as far as I know.
Oh no. Although it does need to be talked about.
Yeah.
So this spotter reported a tornado, and then the Weather Service in Amarillo, and this is all a Twitter exchange, said there's no storm there. That's a bad report. I'll pull up
report.
the.
It's not valid.
Yeah, it's not valid. That's right. They said it's not valid. So, and the spotter apparently had photographs and video of a tornado. So,
Oops.
I know. And again, look, I'm not. This is what people are talking about. Okay, so from the Weather Service perspective, and we got Kevin Laws and some other. Look, anybody want to comment on this story? Anybody afraid of offending somebody?
It's not how I would have handled it on either side. And I think both in after the dust settled, you saw apologies from both sides. I think that's an acknowledgement that neither side handled it the way they should have. In my not terribly humble opinion, Amarillo should have said, all right, thanks for the information. Apparently they did ask him for clarification on location. That was not provided. But, I think there are perhaps better ways to handle that than that's a not valid report, blah, 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 and just sort of writing it off. Even when people call the station and report stuff all the time. James, I'm sure you've had this as well. People call and they tell you all kinds of things. And I give you this story. I worked a severe weather event when I was in Abilene. Nasty-looking supercell rolled through Knox City, which is in, I think that's in your county warning area, Rick.
Yep.
This is probably 04, 05. I'm chief. We had to bail from my eventually news director's wedding because of the tornado warning that was issued on this storm as it was moving in toward Knox County. We get and at one point I had somebody call and she said, the hail with this storm is incredible. It was so big it busted holes in the wall of my house. And under normal circumstances, I was very tempted to just tell this woman, you are nuts. There's no way. Not a chance. Forget about it. But I said, thank you very much. We appreciate it. Well, it's a weekend, it's small market, you go where the news is, and so we sent our crew up. This was a Saturday afternoon. We sent our crew up on Sunday to go check out whatever damage we had. Sure enough, there's a whole neighborhood full of mobile homes where the hailstones were softball sized and they had punched holes through the sides of walls, through roofs, through car moonroofs, the whole 9 yards. Moral of the story is, it may sound crazy, and just because it sounds crazy doesn't mean it's not true. So on that hard, I would say Amarillo probably should have just rolled with it. On the flip side, Mr. McGowan probably shouldn't have been quite as rude in his response to Amarillo, and I think the fact that you have apologies on both sides now sort of says that. I think everybody has seen perhaps we could have handled this better, and I think that horse is dead, and I think we can move on.
So Kevin, you're the closest to the action. What do you say?
Because I'm closest. It seems to.
And by the way, Kevin, I think you got the wrong mic on. You got your internal mic. No, and again, I put a screen share for a split second. I forgot there was some salty language.
Yeah. Like I said, apologies, all that.
Is that better?
More
yeah,
better.
you're good. You're good now. Go.
Yes, it seems like it got rather heated rather quickly, which was unfortunate, passions flaring, but that seems to shine a little bit of a light on, and I'm going to lean on Rick for an answer to this one, shines a little bit of a light on the tension that is going on in that space. And I wonder if, and I think this has maybe been floated in some way, shape, or form before, but I wonder if the local weather service offices have any mechanism or any desire to have some sort of approved chaser list, quote unquote, to avoid this kind of a thing. Rick?
I personally, I don't know how that would work. I don't know who would be on the approved list, who would do the approving. I don't know I can't imagine the logistics of something like that. I mean,
we do so well with the no-fly list. We certainly probably would have a hard time with a no-chase list.
Exactly. I mean,
well, at some level, don't you have? And I'm not suggesting you have to do this, obviously, but at some level, you kind of know the regulars on your beat. Would that be a fair statement, or no?
I know some of the names. I don't know all of them. I mean, it's back in 1995. It might have worked. You had a really short list of chasers, but now there's thousands of people, and there's new people all the time. Sometimes it's the brand, and you can't really go on seniority. You can't really go on how long they've been doing it or how much name recognition they have. There's veterans out there, that may not be as reliable as a brand new person. I'm not thinking of any names. I'm just saying that it's very hard to gauge. It's almost impossible for any weather service office to know who are the quote good chasers. Who are the ones. I mean, there's a handful of names you instantly recognize, but I mean, I kind of knew this gentleman's name, and I had seen him before reporting things in our area. He helped out a lot back in May with lots of reports. So, but I think it's really tough for any forecaster to know who it is, and like Nate said, that there were some misunderstandings and some different wording could have been chosen. I'm going to say right up front, we had an instance just this year where we said something on Twitter that we wish we could reel back in. You can't. Once it's out there, it's out there. And what the intent was, what the meteorologist said to the Amarillo office, what his intent was, or his or her intent was when they said that, I don't know. Were they just trying to say, hey, we're not sure if this is a valid report yet, don't say anything, or was he calling the guy, out for a false report? I wasn't in either place. I'm not going to judge or say, but it's a lesson. We're gonna use it as a teaching moment in our office to just kind of say, hey, you typing something on Twitter, you cannot read my emotion, you cannot read my intent, you cannot read my tone of voice or see my face. It's just words on paper, and it's always tricky when emotions get worked into that.
And when you factor in, Rick, you and Kevin are the only two on the call right now. Forgive me, Eric, if I'm speaking out of turn here, but you and Kevin are the only two. Kevin Laws, that is our guest, are the only two that have ever worked a warning desk in an environment, in an event where you've got potential tornadoes on the ground. That's a very high pressure thing, and I have to respect that. It's not an arena that I've worked in, and you're busy, you're really task saturated at that point. You're trying to do the best you can with what you got. And I don't fault Amarillo for being skeptical. The radar presentation on that storm was capital N, capital I, not impressive. In the moment, you look back at it and you can see, well, maybe there might have been that kind of thing. So I don't begrudge them being skeptical, especially given that there have been some false reports. But this is the kind of thing that we all need to get together and work on together. And in the moment, like I said, perhaps better language, better choice of words. But that's why they call it the fog of war. Things happen, things get said. Hopefully, the damage is not irreparable between the chasers and the weather service, because they really do serve a major purpose in getting reports out. And I think that's something that we all acknowledge.
I think there's a road bump. There's probably 2 points for me here, and one of them is that, and we've experienced this before, and James and you, I don't want to get anything started, but there's been a couple of years gone by, and we had a very similar situation where we had a spotter report, and when you're in that heat of the battle, and Nate and everybody, Rick makes a good point. Your emotions are already at level red, right? So how do you keep that in check all at the same time? Thank goodness for us, probably Twitter wasn't around then, or we weren't, on it. But something similar might have happened. But I'll go back to something I learned as an intern. An older and much wiser lead forecaster told me. He said, never ever underestimate your people out in the field. Never do that, because if you do, they're going to prove you wrong almost 9 times out of 10. So I've always stuck to that rule. Something always stuck with me through all these years, and I thought, well, my people in the field say it on some level. Unless it's just preposterous, I've got to at least entertain it and see if it goes anywhere. So at least it's worth investigating if you hear about it.
That's really good.
I think somebody mentioned the word tension. There does seem to be some, and there has been tension between the Weather Service in general and the storm chaser community in general. Our office, we get along fairly well with all the chasers. Are we going to issue a tornado warning every single time somebody reports a tornado? No, we hardly ever issue a tornado warning based on a single piece of evidence. But that doesn't mean we don't trust the chaser. That doesn't mean we don't understand. I mean, there's factors that go into it. It's much more complicated than just tornado report, issue a warning all the time. Now that's going to sound very unusual to some people, and Kevin, you can come out on this limb with me, Laws, if you want. But it's not always that easy to do. So it is a tense situation. But I mean, I think just communication. I think I was glad to see the apology from Amarillo and the apology back from Mr. McGowan, and I think we're ready to kind of move on. But we can't move on from the discussion. It is an important discussion, and this is something that goes on not only with spotters, but not only with chasers, but spotters with the TV stations. This kind of thing happens all the time at different levels. This just got unfortunately escalated because of social media.
Yeah,
and I think the teaching moment here probably too is as much as we don't want to admit it, social media is sort of new to a lot of people, especially people like me. So I got to be really careful about when your emotions are high. You just want to be real careful about exactly what you say. In fact, I would just recommend, if you're in that situation, to just have someone else doing it, not you personally. So if you're ever in that kind of situation.
I think we need to get both parties on this show. I think we need to get Dick McGowan and somebody from the Weather Service in Amarillo, the guy that wrote that tweet, on this show so they can kiss and make up to the Weather Enterprise. What do you say, Bill?
I don't know. Okay. I think they've already done that. I think there's like Rick said, there's maybe a greater conversation involved, but to drag out this between these two individual parties who have clearly kissed and made up on their own without any involvement from us, I think to sort of drag that out is sort of beating a dead horse. But, Kevin, Selly, and Rick are right. There's a broader conversation here, especially in some of the plain states and in Texas, between the Weather Service and the chaser community and spotters that perhaps could be improved. And that's an ongoing thing. I mean, it's never going to stop. And I think it's just a conversation that needs to continue to happen. And if Eric and his project are successful here in the Southeast, we may have to have similar conversations here.
Before we move on, I will put a cheap, shameless plug in for the. I'm going to be. I'm actually have the honor of speaking at the National Chaser Convention. I think I'm still speaking. I'm not sure, but I'm going to be the last speaker on the last day. And before this ever started, my topic was going to be behind the scenes of WFO warning operations, because I think chasers don't really understand what's going on in the office. And I'm not being disparaging. I'm just saying they don't have any idea what's going on in the office. I want to give a little bit more insight about what's going on, what we're doing with those reports. There is no grand conspiracy to hide tornadoes or anything like this. There's all kinds of misconceptions. So and I'm sure this will be a topic. But Norman, I don't know the dates. It's like mid-January, but should be interesting.
Hey, Rick, you can unveil your no chase list then, your project.
There you go. We'll just roll out the list of names.
Maybe Rick and Kevin could tweet out selfies of yourself each time you send something out, and then we can know your tone, whether you're smiling or your hair's on fire.
We need warning forecaster emojis.
Yeah.
Oh, brother. All right, so let's do this. So Bill, formally introduce our guests, and then after you do that, before we get in, this is a subject dear to my heart. I can't wait to hear this show, but I'm going to run the some segments right before we get into it. But first off, Bill, let's bring on Eric and Kevin formally here.
Yeah, thanks, James. The brainchild behind tonight's show is no stranger to WeatherBrains. He's appeared several times. He's the Science and Operations Officer at the National Weather Service in Birmingham. Kevin Laws, welcome back to the show.
Hey, thanks for having me. Great to be here.
So, Kevin, I know you're involved in Vortex Southeast. Can you tell us what the acronym means?
Well, yes, this will be the third, and it's really basically what it says. We're going to be studying vortexes across the Southeast. So
there you go. All right, I was going to see if I could catch you off guard if you could tell me what vortex meant, because I'm not sure I could tell you what it means. I bet our other guests can though. Can you?
I know.
All right, Nate. What do you say, Nate?
Verification of the origin of tornado experiment.
Rotation.
Vortex.
rotation.
Well, or origin, so I was taking 2 words from origin. But partial credit.
Kevin, thank you so much for putting the show together tonight. We're glad you're here. We want to talk a little bit later, too, about some of the cool stuff you guys continue to do at Birmingham in the warning process. So thank you for joining us tonight, especially since you had to leave your daughter's Christmas cantata or something early to be here.
Yeah, she did great. So got it on. I was uploading it to YouTube there, so we're in good shape.
Well, awesome. Well, maybe that'll be your pick of the week. But tonight's guest weather brain is one of the world's leading experts in mesoscale meteorology, severe convective storms, forecasting of storms, and tornadogenesis. He was the field coordinator in the original Vortex project, and also was in Vortex 2, of course, but he'll be the program manager for the upcoming Vortex Southeast Field project. Dr. Eric Rasmussen, welcome to WeatherBrains.
Thanks, Bill. It's good to be here. So that Vortex acronym, I saw it on a website recently before the website went public. It said it was the verification of the rotation in tornadoes experiment. And one of my colleagues quickly pointed out that we've known for a long time that there's rotation in tornadoes.
So it has been verified. That's good.
We left the origins out, but now they're in there.
We spent $3 million to verify that they rotate. That sounds like a government project right there. But, Eric, it's the holidays, and of course at holiday gatherings you sit around and you listen to family members talk about stories. So we feel like we have a long-lost uncle that we've never had on the show that we've always wanted to have. So tonight we're going to be really excited just to hear stories from Uncle Eric. So I know James wants to do some recorded segments, and we'll be back in a minute to talk.
I want to hear some Chuck Doswell stories, Eric. You got any of those?
I probably better not do that.
All right.
Chuck still lives in the same town.
Yeah.
Do it to you.
So what we're going to do, we're going to pause very quickly for Brian Peters. Now, Brian is in Chicago tonight with his daughter. He's out. But we've got WeatherBrains 101. Tony Rice in the astronomy report will come back and do the fog bank and email, and then we'll get into Eric and Kevin. This is going to be a great show tonight, so do not go away as WeatherBrains rolls along.
WeatherBrains 101 with Professor Peters.
Meteorologists have no lack of clever terms we use in our daily description of the weather. One of those is bombogenesis, which is when cyclogenesis occurs to an extreme. Now, cyclogenesis is defined in the glossary of meteorology as any development or strengthening of a cyclonic circulation in the atmosphere. This basically is the development of a low-pressure system for us in the northern hemisphere. You won't find bombogenesis in that same glossary, but the term bomb is there. It is defined as an extratropical surface cyclone with a central pressure that falls on the average of at least 1 millibar per hour for 24 hours. The height contours pack around the center of the rotation, and the number of height contours increases rapidly in the developing stages. The most common time of the year for bombogenesis to occur is in the cool season from October to March, when the temperature gradient is large between the high and mid latitudes. It is also predominantly a maritime event. Bombogenesis typically occurs between a cold continental air mass and warm ocean waters, or between a cold polar air mass and a much warmer air mass. Many nor'easters are products of bombs. The contrast in temperature between polar air spilling over the eastern U.S. and the warm Gulf Stream water sets the stage for cyclogenesis on the boundary between these air masses. While it may be found predominantly in maritime environments, sometimes bombs will develop in the central U.S. between the boundary of polar air and more tropical air. Cyclogenesis that results in bombs requires strong divergence aloft. This divergence aloft is supplied by a strong jet streak diving into the trough axis aloft from the developing low pressure. The momentum of the jet streak and the dynamics in the left front quadrant of the jet streak cause a rapid evacuation of mass above the region of cyclogenesis, resulting in explosive development, hence the term bombogenesis. Leave it to meteorologists to make the description of atmospheric processes more exciting. If you have a question about the weather, drop an email to question@weatherbrains.com.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
If you are listening or watching to WeatherBrains Live, please stop, at least for a few minutes. Pause the live stream and go outside. James and the rest of the Weatherati will be waiting for you when you get back. The Geminid meteor shower peaked this morning around 2 a.m. local time, but there's still time to see the show, weather permitting, of course. Give your eyes a few minutes to adjust and look towards the darkest part of your sky, away from any unshielded lights. While you won't be able to see this morning's peak of about 1 meteor per minute, plenty of meteors should still be visible in this, the most active shower of the year. Elsewhere in the sky, you may have seen graphics on Facebook or Twitter claiming that there will be a full moon on Christmas Day, the first time since 1977, and that this won't happen again until 2034. While a healthy skepticism on this kind of information being shared on social media is a good thing, this one is actually 100% true. Looking at the 250-year period beginning in 1900, a full moon falls on Christmas Day only 10 times. This current 38-year drought, though, is a bit unusual, and the 19-year wait coming up next is quite common. The irregularity of a given lunar phase falling on a given date is because the lunar cycle of a little more than 29.5 days doesn't line up very well with the tropical year of a little less than 365.25 days. Interestingly, though, the last time a full moon fell on Christmas Day, another Star Wars, this one, Episode 4, was in theaters. That's your Astronomy Outlook. Follow me at RTP Hokie for more spacey stuff like this.
Letters. We get letters. We get stacks and stacks of letters.
All right, so this just in. Thank you. Thank you. This is in from Joshua Mumbrew.
We interrupt this program for a CBS Radio Net Alert Bulletin.
Mine was faster and more timely.
Joshua says, I am sick of this warm weather. Shame on you, Joshua. Enjoy it. It's gorgeous. But Joshua also says, what is your opinion on this winter? All of the winter storms have been in the western half and plains of the U.S. Darn those Westerners. I feel like the eastern half will be due for a winter storm next month. Plus, Wisconsin and Iowa. I tried to combine the two. Do you see that? Wisconsin and Iowa had a soaking here yesterday, and this morning over 2.5 inches here where I live.
I'd just like to point out that once upon a time, people made fun of me for wearing shorts in December.
And now it's the in thing.
I was stylish ahead of my time.
I do find it interesting the storm track of a lot of these storms lately. How a lot of them have kind of been missing a lot of the East Coast.
Completely.
Yeah, Dr. John is going to tell us what the rest of the winter is going to be like in the East. Dr. John, go.
Oh, I am. Oh, thanks, James. Now that I finally joined the program.
Yeah, but they see that the last one, Ing, is the hardest question, so
yeah.
go.
Well, this is going to be a backloaded winter, if we get winter at all, particularly in the East. You know, the storm track coming out of the southwest and moving through the Rockies and the Great Plains, that's going to be the case, I think, into January. So we had the third warmest November on record here. So far, this is the warmest December on record. We've had 2 straight days of record highs here. and I'm still at 63 degrees. This is absurd.
I'm at 64. I feel you.
For those that don't have the video, Dr. John is wearing a tank top and flip flops tonight on the show. You might not want to watch the video version.
So we'll see what happens in a few months, but enjoy the warmth while it lasts. All right, Charles Prevet
Can I break in, Aubrey? I'm
yes,
sorry.
Yes, go ahead.
We have a thing
breaking
here.
News?
No. We have a thing here. They do the first in the summertime. They do the first 103 degree day, and then the first freeze. We have a first snow contest, and I'm getting a lot of static from people because it's been pretty mild here. So I went out on a limb today. I'm saying no snow for Wichita Falls this winter.
Wow.
Yeah.
Wow.
And what's your average? What's your average?
That's an excellent question. I would have to go look that up.
I'd say you're working without a net, Kevin.
Well, I expect to be coming to you next week from my next job, or in the spring, where I'm off to solve another drought problem.
You can just blame the Weather Service people.
Good idea.
All right, we have another email from Charles Prevet. Here's a recommendation for someone to use as their pick of the week if anyone would like to use it tonight. The article is okay, but hearing Jack King do the count and seeing all 13 Saturn V launches side by side is pretty cool. And it's from physicsastronomy.com about the Saturn launches. Very cool. Devin Greeny said, thank you for your thoughtful plea from both sides about last week's climate change. I'm sick of one side and the other side, so he appreciates us as we keep up the search for the truth. Thank you, Devin, from Memphis, Tennessee. And Ken Hoagland, a frequent emailer, fairly frequent, occasional, sent this in a few weeks ago, and I think I missed it. I think I put it in a wrong folder. And I will let Dr. John answer this because he's actually answered this before, I think a few days earlier. So Ken says, so I was looking through the BBC website and came across a series of pictures of flooding from Storm Desmond. So apparently they named storms in the UK and who supplies the names and what criteria triggers a storm being named. I know this is not a new thing, Dr. John. Do you know who supplies the names? The UK Met Office?
Yeah, it's the UK Met Office that's doing that. And I thought they just started this fall.
It just started this year.
Yeah,
I thought it was
October. I think
Okay.
October was when they made the decision, and it's
probably
based on impacts.
Yeah,
So-
you're probably thinking, Aubrey, of the Germans.
The
University of Berlin names high pressures and low pressure systems
Yes.
every year. They go across Europe, but the Brits and the Irish have not partaken in that until now.
Okay.
And now they come up with their own names, and as John mentioned, it's more based on impacts, whereas the German system, I think it's any high or
Just
low that
any.
meets a certain criteria, certain set of criteria.
That can get confusing, it sounds like. All right, so if you would like to send us an email, send it to email@weatherbrains.com. We'd love to hear your guest suggestions, your questions, your emails, your link suggestions, what you like about the show, and also some topics for the show. We'd love to hear that. You can send that to email@weatherbrains.com. Don't forget to find us on the Twitter and the Facebook. Just search for WeatherBrains.
Again, I think this might be one of the greatest shows ever. But before we get to Eric and Kevin Laws and Bill Murray in this topic here, I'm going to roll the fog bank because this is a recorded segment, and I've got to roll the recorded segments here. We'll do the picks of the week at the end of the show, but we're going to move Skydiver up right now.
Initiating startup sequence.
Hello, WeatherBrains listeners. This is Dave Phillips with the Fog Bank. My first pick comes from stormtours.com with an explanation of their forecasting. My next two picks are photos from Earth Science Picture of the Day. The first one is a red sprite taken in Greece. The second one is a low rainbow taken in the Sierra Nevadas. I've also got two aurora photos. The first one from spaceweather.com and a great one from Astronomy Picture of the Day. James, don't step on my clothes. Thanks for listening. Skydiver out.
Initiating shutdown sequence.
And I have done that in the past. So, all right, Bill Murray, I think Bill is back on the show. Bill hung up on us here a second ago, but he's back with us. I thought somebody made him mad.
Yeah, something hung up. I'm not sure what it was, James. But anyway, I'm back now, so I had to go out and come back in. So anyway, it seems like a tradition on the show for me. I get to do that at least once every show. But I'm just fascinated tonight. I thank Kevin again for getting the show together. But Eric, you're one of my heroes, and somebody I've always followed and always wanted to have you on the show. So I'm glad we got you on here. But I want to go back and talk about 1 and 2 before we get into Southeast. So you were the field coordinator for Vortex 1. So Talk about some of the hypotheses that you originally were testing and what you felt like were some of the biggest outcomes out of that field experiment.
Well, in one was in 94 and 95. I guess I'm still here.
Yeah. You're loud and clear.
The hypotheses, it was the first experiment I've been associated with where we actually tried to put together hypotheses, and that was, I think, by the inspiration of Chuck Doswell, to tell you the truth. But he kind of insisted that we go with testable, refutable hypotheses, which is a good way to do science. And the program in 94 and 95 centered around, well, where is the rotation for tornadoes coming from? We kind of knew that they were associated with mesocyclones, and I think the popular notion was that somehow a tornado just built to the ground out of a mesocyclone. We really didn't have any physical explanation for how that happened. So a bunch of scientists came up with hypotheses for that, and we wrote them all down and tried to design a field program around that. In reality, it's probably not. We could probably do things better now in terms of the way we formulate the science, because we were making silly hypotheses like, in a sufficient sample of tornadoes we will see such and such. Well, a sufficient sample of tornadoes is probably 50 or 100 tornadoes, and no field program is going to see that many tornadoes even in 10 or 20 years. So that's a kind of a lame way to write hypotheses, but it's better than nothing, because it actually, it allows you to think about the kind of data you need to collect to learn something. So that was kind of cool. And I kind of put that program together and was the field coordinator for it, tried to do some primitive coordination. One of the things we pioneered was I had a primitive GIS system on the desktop in our coordination vehicle. And we didn't really have any way to communicate position back and forth. There was no way to telemetry that via radio in those years. And so what I had field teams do was look at their GPS and read off the last 3 decimal places of the latitude, the first 3 decimal places of the latitude, and the first 3 decimal places of the longitude across the radio. And then I would key them in on a little keypad, and the team position icon would pop up on my display where that team was. So that was our high-tech approach in Vortex 94 and 95. And so, I think one of the biggest things we learned was probably that from the perspective we had, which was standing off with airborne radars and whatever we could bring to bear on the ground, the mobile mesonettes, the first primitive mobile Doppler, the tornadic storms looked pretty much like the non-tornadic ones. We really, in the data we looked at, couldn't see what was making them different. So I think that was one of the key findings of the first vortex. And so that, after studying those data for a few years, it came time, the scientists kind of got together and said, well, we think we can do it better now if we observe storms differently with more mobile Doppler radars, closer in, further out, a variety of new observations. And we came up with a whole new set of hypotheses for the second vortex experiment, which was, 09 and 10, if I remember right, my middle-aged memory. I'm not sure that we really learned a whole lot more about the origin of rotation in tornadoes from that experiment, except that it kind of told us that there were things lurking where it's very, very hard to observe, and those things were probably pretty paramount in understanding why tornadoes form. And by that I mean what's causing the actual tornado to form is probably something that's going on in the lowest few hundred meters of the atmosphere above the ground. And even your mobile Doppler radars, standing 10 kilometers apart, tend to observe just a little bit above that and then up through the storm. So there can be some vitally important stuff that lurks in places that are extremely difficult to observe.
And so how is that folding into your hypotheses for the Southeastern Field Project? Is it totally different, Eric, because of where it is in the country, or are there still some that'll carry between the projects?
I think the biggest constraint in the Vortex Southeast is just the rugged terrain and vegetation and the land use. Going into Vortex Southeast, we all pretty much understood that we weren't going to have a tornado chase experiment. That's just not feasible. Even teams that are nimble, like mobile mesonettes, will find it very difficult to make progress on fast-moving storms in an irregular road network with a lot of terrain, not being able to see the sky because of the trees and the low clouds and the haze and all of this. So it's not a tornado chase program. So Plus, I think we understand now that we need some pretty unique new ideas to actually observe those processes going on right in the lowest part of the atmosphere that cause rotation to congeal into a tornado. So that can't be done, obviously, in the southeast U.S., and it's very difficult to do even in the Great Plains. But what we can do, now that we have this idea about what's probably going on near the ground, is we can probably observe much better those processes in the storm that's leading to that near-ground rotation. That's almost always tied up with downdrafts, and the way that downdrafts are associated with slightly cooler air leading to the horizontal spin, which they then carry to the ground and toward where the tornado will form. So in terms of the tornado science in Vortex Southeast, this is going to be about how storms create the spin that eventually becomes the tornado. And I ought to add at this point, before I forget, that that happens in sort of unique ways in the southeast U.S. The supercells, of course, happen, and they produce violent and tragic tornadoes. But there's also a variety of other processes leading to tornadoes. For example, in these what we call the quasi-linear convective systems, which are just strung out bands of thunderstorms with sometimes embedded supercells and other types of storms in that band. It appears that they're actually producing tornadoes in ways that are probably different. They're setting up that rotation that leads to the tornadoes in ways that are probably different than the supercells. But anyway, before I talk forever, which I could do, I probably ought to listen for a question.
No, that's okay, Uncle Eric. That's why we have you on the show tonight. So that's exactly why we have you on the show. So I was interested in reading your paper about the program. Eric, some terms came up that are relatively new to some of us as meteorologists, and Kevin, Laws, you jump in too. But things like what is a horizontal vorticity streamer, and what do we know about it at this point?
I can say something about that. That's the feature I was just now talking about, this hiding below even the mobile radar horizon. When this cooler air sinks in the downdraft parts of the storms where there's like aloft there's melting hail and graupel, and then that cooler air and the heavy rain subsides toward the ground, that patch of cooler air leads to spin where the air is sinking in the interior and then rising just outside of that. So that leads to horizontal spin. Then the downdraft carries that horizontal spin on all the way to the ground, leading to bands of this rotating air. It's like rotating like a rolling pin as it moves along toward the storm's updraft. And that's going on perhaps, it's hard to say exactly how deep that is, but it could be as shallow as maybe 300, 400 meters deep. But intense, almost tornadoes intensity rotation, but in a horizontal sense. So that's your horizontal vortex streamer. It streams toward the updraft, and then and my opinion is it's almost, it might actually almost be sort of just bad luck for the people out there that this horizontal streamer finds itself under a low-level updraft and then gets abruptly turned upward and then stretched and tightened up to sufficient strength that it can start doing the damage and be called a tornado. So the horizontal vortex streamer is a thing that comes out of the rainy part of the storm, moves along the ground, and finds itself under an updraft and has the potential of producing a tornado.
So this is sort of like dark energy or something, Kevin. How will we find this, Eric? I mean, how will we eventually be able to search for that if this does prove to be pivotal in the formation of tornadoes?
I wish I knew how we could find it in a research mode. There's certain ideas we can try, like putting vertically pointing wind profilers of the low levels along that rainy edge of the storm and letting the storm move across and see if we can detect this sudden increase in horizontal rotation as it moves by. But when it comes, at this point, my best idea is that when it comes to eventually detecting these operationally, we're going to have to detect the things that we know lead to the horizontal vorticity streamer, like a signature in the dual polarization of the radar, where it shows us the kind of particles we're looking at. If we can perhaps see a signature of where there's a graupel core or a hail core descending toward the ground, then we can assume, hey, this thing might lead to a horizontal vorticity streamer, and it's close to an updraft. We've got to really pay attention here for the first signs of rotation on the radar. But that's about the best I think I can do at this point.
Well, that's fascinating, Eric, and it's huge for us as operational meteorologists to begin thinking about things like that. Who came up with this brilliant concept? Is there one group or one person that came up with this idea?
I don't think so. I think it's actually shown up in the studies of several numerical modeling studies lately, and at various institutions. Some of them, there's some subtle differences. Is the rotation completely horizontal, or is it slightly vertical as it's coming toward the updraft? There's some subtle differences like that, but several of the computer simulations are showing this, and so I think it's becoming kind of a more popular concept of an issue we need to look at.
Now, you briefly touched on the downdraft and its role in tornado genesis, and that's popularly, I guess, what everyone believes is pivotal in the formation. But talk about the evolution of that theory and that concept, Eric.
Yeah, that concept, that started with Davies Jones back in the 80s. He identified it through his logical chain of thought that it had to be the downdraft that would get the rotation near the ground, because the idea was that if the rotation's not at the ground initially, then it comes in toward the storm updraft and it gets turned upward. Well, it's not at the ground anymore, and that's where it has to be for a tornado. So he identified the idea that the downdraft has to be critical, and then there's been a number of studies over the years. I guess, when you go back and look at the historical numerical simulations, you can see this feature in a lot of them, but it just didn't really grab people's attention until perhaps maybe the last 5 years. It really started standing out, and we had to give a lot more careful thought to it.
So you begin to feel sort of like Hawking and the black holes in the 70s, huh? You had to you dream them up before you find out when you see them in the computer and you realize that they could be happening, but proving that it occurs becomes the eureka.
Yeah, it's kind of a nice interplay. I think we've gone back and forth between observations and simulations in tornado science all along, and now lately I think it's been probably the numerical work that has led to some new ideas, and now the challenge is to go out and observationally and see if we can validate those ideas.
Of course, our topography here in Alabama in the southeast is something you've already referred to, and it is something that we talk about all the time. And old timers will say, there has to be something to that, and a lot of research is tied to that. I know you're going to talk about land use and topography and things like that. Talk about some of the exciting things you think will come out of this project in relation to those ideas.
That's something I've been looking at today. We're trying to put together what we're calling the research roadmap for Vortex Southeast. We had a big workshop in Huntsville last month. 100 scientists got together, and we kind of went through a 2-day process of starting with the big picture of Vortex Southeast and working down to what the real research questions are. And I've been trying to get those written down for all the agencies. And one of them is the terrain issue. There's people who have anecdotally seen what they believe is evidence that tornadoes are associated with terrain, not only in where they form and dissipate, but in how they change intensity, and even the paths might be deviated by the terrain. But that's anecdotal. There's really we don't have any systematic scientific studies of that yet. So that's something we want to do in Vortex Southeast. And then I feel one of our biggest challenges is how the heck do you even quantify the way the air flows through really complex terrain? If you want to park a couple of Doppler radars down in a valley and a couple up on a ridge and have them scan, you're still going to have places along the terrain that aren't seen well or that you really can't analyze the airflow. So I think one of the big things we're going to try to do early on in Vortex Southeast, assuming it's an ongoing program, is learn how the heck do you observe the wind flowing through complex terrain, because if we can't observe it, it's going to be awfully hard to come up with good conclusions about how it's influencing the storms and influencing the tornadoes themselves.
So Kevin Laws, I'm sure that a focus will be up there around Lawrence County, where that land drops off onto the plains between Decatur and Huntsville, and that area, huh?
Yeah, I think a lot of the field experimental part of it will be on the northern side, northern half of Alabama. So, they already have the armor radar up there, I think, that WHNT and UAH share. So that goes into it as well. So that it's kind of a combination of a couple instruments that'll, be important as we start looking at the data and analyzing. I'm just, we've been so dry and it's in such a dry spell, knock on wood, that we got to get some storms to look at. So it's been part of the problem. But it's too bad we couldn't start this week or this month, because we're back in that southwest flow again, and so we got a couple opportunities, I think, over the next few weeks to get a couple outbreaks. So we'll see. But Eric brings up a good point, and the challenge for us and bringing it full circle is, we talk about this, and what he's talking about there is that bottom-up tornado theory, where it's forming from the bottom of the ground up instead of from a mesocyclone down. And, it presents a warning challenge unlike any other. First, you can't see them on radar unless it's right next to the radar. And so half the time we're going to be trying to make an educated guess as to where to put out a warning if one's needed. And so I think there's a lot of challenges bringing that full circle.
Well, these topics are absolutely fascinating, and another one that appeared to me that piqued my interest, Eric, in the material that I read online was the idea of cold fronts aloft in the southeast, and they really do seem to have an impact in severe weather events. Have you studied that very much, and what will we be looking at in regard to that in the experiment?
No, I personally haven't, and that is something that will be looked at. That's an idea that's sort of been championed by Dr. Steve Koch here at NSSL, our director, and he's noticed in formal studies he's done in the past that it looks like the cold air does move in aloft sometimes first, and of course that allows the atmosphere to destabilize. With cold air overlying the warm, humid air really leads to a lot of potential buoyant energy for the air. So that particular topic is one I'm sure we'll be looking at. I don't think it will happen this spring, when the focus is going to be more on looking at processes near the ground. I can go into that more in a minute, but I think down the road, either in 2017 or even more likely in 2018, the cold front aloft is going to become a pretty important topic.
And rapid destabilization becomes a problem for us here. I know for Nate in North Carolina, it's been a problem in past events. That obviously has an important role too. Talk about that for a second.
Yeah, that's going to be a big one for this coming spring. It turns out that in the grants that we've funded from NOAA for this spring's research, there's going to be an awful lot of soundings launched. I think we have 6 teams launching soundings, and they each have a lot of sondes available to them. So we're going to have soundings all over northern Alabama, and we're going to start launching about a day before we're expecting the onset of severe storm. So we can actually go from the time when the atmosphere is stable and quiet through that whole period of the rapid destabilization, as it really becomes warm and humid near the ground rapidly, and the shear increases very quickly aloft. So we'll observe all of that right on through the episode of storms until they move on by. So I think this spring we're probably going to learn quite a bit about the rapid destabilization and the rapid increase in shear that goes along with these southeast U.S. events.
And one of James's favorite topics are QLCS tornadoes. So I'll ask you and ask Kevin to jump in, and I know Dr. Scala wants to ask a question. So talk about QLCS tornadoes and how we as operational forecasters can improve our skill in that regard based on the research that you guys are seeing now.
Boy, I wish I could tell you. I can't. I'm not an expert on them, but the ones I've looked at they're pretty mystifying. I think there's different processes going on from what I've seen with the different tornadoes. Some of them might be sort of a shearing issue along the leading edge, where that wind shift along the leading edge actually rolls up and causes a tornado. Some might be supercells. There might be other processes that we haven't even thought about. So, that's going to be huge. I'd like the other guys to talk about that because they're a lot more informed on QLCS than I am. But I think as Vortex Southeast goes on, the QLCS tornado mystery is something we're going to have to work really hard on.
Kevin, anything you want to add to that?
Yeah, I agree. I mean, they're just like supercells. They're not all created equal, and so you have QLCSs are like the morning of April 27th that do tremendous damage, and then you sort of have it's like a sliding scale from what we just probably experienced overnight last night, which is nothing, all the way up until that. So we've really got to understand these processes better, not only from a forecasting standpoint, but obviously a warning standpoint as well. And I think that's why it's such a hot topic, because that's almost like sort of like QPF in the models. It's the last frontier of some of the last frontiers of severe weather forecasting is how that works. And I always challenge our folks because we seem to throw out QLCS a lot, even in the forecast process, and I don't even think from 3 days out can you determine what mode of convection you're even going to have. So we're almost at square one with a lot of these science problems.
And before I ask the question I wanted to ask, Kevin and Eric, first, let me welcome you to the program. I was a little bit late arriving, had some technical issues at my end, but glad you're both here. The first question I wanted to ask deals with these QLCS issues, and what we seem to find here is often a transition from these convective modes, discrete to linear to then potentially a flooding event. So that, to me, is going to be I think a horrific challenge in this study, trying to deal with days in advance what kind of convective mode you're going to be dealing with, and then how those transitions might occur.
John, I have a comment about that. We have this concept in Vortex Southeast that we're going to go out. We're kind of expecting maybe 4 to 6 frontal passages or wave passages in a 2-month period, March and April, and we want to be out there and observe the whole duration of each of those things. And so we don't want to anticipate or build our strategies yet around our anticipation of the mode. Instead, we're going to just set up a good network that's capable of observing whatever mode occurs, and then just take whatever Mother Nature throws our way.
Great strategy. Great
Thanks.
strategy. I hope it works.
So do I.
I wanted to share a picture with you here. This is from some work that Paul Markowski has been involved in with his colleagues, and I think he's been championing this particular process of this very important interaction between the updraft and the downdraft. This is from a paper that he wrote that was published with his colleagues in 2008, and he's talking specifically about this interaction, Eric, that you mentioned, where there's the downdraft is transporting the vorticity to the ground, and then it interacts with these updrafts in very close proximity. And it seems to me if this is a mechanism that is of interest for your study in the Southeast, positioning the crews observationally as well as remotely to actually sample this environment is a big challenge.
I agree with that, and in fact, my sense, until someone proves me wrong, my sense is that it's impossible. And in fact, to observe what's going on in that lower right-hand leg of that picture you showed,
right.
I think we need, it's going to have to be the kind of terrain and land use that you're showing there, and we're going to have to be so awful darn lucky to place 2 Doppler radars about 5 kilometers apart in just the right spot and have that process occur right in front of them. And, you know, if with enough years and enough luck, it's going to happen, and that's going to be a tremendous achievement. So I think for now, we're going to have to try to focus on those downdrafts and what's causing them. And we're going to have to make heavy use of the numerical approaches to continue to investigate the physics that are happening near the ground.
Thanks, Eric.
Hey, Eric. Just as what was learned in Vortex 1 and 2 has applications in areas outside the Great Plains, I think it's important for people to realize that things that are learned in Vortex Southeast are also going to help us in other places. I think there's a misconception sometimes that Oklahoma and Texas and Kansas get all the big shooting fish in a barrel, big classic supercells, and that's all we get. And all the storms in the Southeast are very dramatically different. Well, we get, as you know, our fair share of QLCS tornadoes here, and I think that's going to be one of the most interesting aspects of any study in the Southeast is we're looking forward to the benefits of that, because that's something we struggle with just as much in Oklahoma, maybe not as frequently, but it happens enough. I wouldn't want to deal with it any more frequently. So I mean, that's a huge issue, and so I'm looking forward to that. But I think it's important to know that storms don't really know where they are. I mean, sometimes people think that too much, and there's plain storms and southeast storms, and so anyway, I think the findings of this are going to benefit obviously the Southeast, but everybody. Would you agree with that?
Yeah, I definitely agree with that comment. And to me, with the state of the knowledge of tornadoes being what it is, I'm happy to study them wherever they happen. I mean, put me on Mars if you want, but we really don't know as much as sometimes maybe we pretend to know about tornado formation. So let's study them every chance we get. And Rick, along the same lines is maybe half of what we're doing in Vortex Southeast is along the lines of the social sciences. The people who do those sciences don't like that term especially, but it's things like, I have to look at my own list here, risk perception, behavioral studies, communication, anthropology, all those sorts of disciplines. We have a lot of that going on in Vortex Southeast because we want to understand all the way from the detection of the phenomenon that is this Weather Service's task, all the way through the communication chain down to the end user, the citizen, and even the sort of ideas they have about tornadoes and the preparations they have done. We want to understand all those things in the Southeast U.S., and obviously a lot of that will be applicable everywhere and even in disasters besides tornadoes.
So Kevin Laws, your office has been at the forefront of that with Dr. Laura Myers and different things, and I know she was at your office today. Yeah, anything you can shed on what you want to see come out of the project and in relation to the social science work?
Yeah, absolutely. She was there today, like you said, and we were actually discussing maybe a tiered watch system, even like in that initial phase of the forecast, even out 24 hours. Is there a tiered watch system that would work to educate folks, to alert folks ahead of time, those who would need to seek shelter, those who need, even up to a 24-hour lead time to start making some preparations. Hospitals, the most vulnerable people in our society, a lot of times are the ones who are the last to get the message, and how can we start to transition that? So I think probably the bigger difference between Vortex 1 and 2 versus Vortex Southeast is now the encouragement to have social science brought on board and sort of look at the entire process from end to end. So we start with tornado formation and we end with our communication strategies and are people taking action and are people doing what they're supposed to during these events, because the goal at some point has to be we have to protect life and property, and are we doing everything in our power as scientists and warning forecasters to do that and get that message and make sure it's very clear and people understand what to do during these situations, because a lot of times that's what we find out is that people don't have a place to go and don't know what to do, and if they're not given specific actions, it's hard. You don't think about it. For us, it's easy because we deal with it, all the time. But for some folks, it's just, it's basically teaching, hey, you need to go here. Hey, this is not safe. And we've seen countless examples of folks, getting in their cars and trying to outrun is a good example. A storm that's coming. So is that the best? Is that the best thing they could do to try to protect their life and save themselves, or is there something else that's important? Is sheltering in place better? So there's just tons of things that we need to look at.
Kevin, I'm sorry, John, you go ahead.
Oh, thanks, Bill. Kevin, on the subject of safety, as scientists and also distributing folks in the field, where do you draw the line as far as safety goes? Where's the envelope? Where do you put that margin so that you protect your assets in the field, both the material assets as well as the lives of the people that are investigating the storms?
Yeah, that's a good question. I mean, it's like Eric was talking about earlier. It's a real challenge obviously with the terrain in the southeast, and probably more than the terrain and land use and trees and vegetation, everything else you got to deal with is that our cloud bases here are probably 10 times lower than they are in the central plains. So you can't see anything. I mean, visibility is basically zero. So safety is going to have to be paramount to what we're doing. I mean, we got to keep our people safe, and short of tremendous outbreak, we're just going to have to. They're going to have to be very aware and have a plan in place before we even deploy out in the field to know what they need to do to protect themselves. Because, like you say, around here the storms move at 60 miles an hour. The cloud bases are practically on the ground, which means the tornadoes are practically on the ground. So they're going to have to, I would say, for me, if I was out there, I would say, okay, guys, here's our plan ahead of time. Here's what we're going to do, and make sure everybody's on the same page before we even got out in the field. So it's just going to have to be a part of it.
Yeah.
So, Eric, go back and talk about 1994, 95, 2009, and 10. It seems like in the 94 part of the first experiment, there was sort of a tornado drought, wasn't there?
Oh, whenever Vortex is in the field, there's a tornado drought. It's the #1 predictor of tornadoes.
So thank you guys in advance. We here in the Southeast appreciate that.
Yeah, we got, a 3-year reprieve? That's pretty good, Nate. We'll take it.
We'll find something to study. No, there was a drought in 94, and in fact, 95 was not too great until about the last week of the experiment, and then it just all broke loose out in West Texas. And fortunately, I guess we'd had plenty of rehearsals by then, so we did all right. But I think even Vortex 2 was pretty much a tornado drought the first year, and then the second year was better. But boy, I tell you what, at least from a planning standpoint, a scientific standpoint, I think we had in our minds a lot more storms, a lot easier to chase, and a lot better data sets. But it's just, I guess, when you're planning things like this, you always remember those great storms that you chased and you got good data on, and you kind of formulate your plans around those, and then you go out to the field and Mother Nature makes a fool of you all over again.
I'm reminded by Eric saying the title that there's an old video clip of him, probably from the Weather Channel, where he said, and apparently you just didn't learn, Eric, well, you should have called it Ridge X, and then you would have had plenty of tornadoes.
Let's see, rotation, identification,
there we go.
Genesis experiment. Yeah,
I'll
that's
keep you busy for a while.
So I'll ask this question to Eric, and then get Kevin to chime in too. How will the National Weather Service offices in the surrounding areas participate in what you guys are doing?
I don't think that plan is complete. I think Kevin may be able to say more about that than I am.
Yeah, he's right. We're still looking at that, and it's a little bit interesting this time around. Unlike most field experiments, most of the funding was put in place before we actually had a plan. So it's sort of us trying to get together a plan after it's in place. But like I said before, this is slightly different than the previous two, where most of it was field observations and data collecting. This one will have a more end-to-end process where we'll be looking internally at the office structure, perhaps, and a lot of social science funding is going to come from looking at internally at the office. In fact, at the meeting, I challenged a lot of social scientists, hey, come sit with us during an actual event, observe what happens, and see if it's really what you think is going on. So you always have a perception of what's happening, and then there's what's really happening, just like we sort of talked about at the start of the show. So I think they would probably be fascinated. There's a lot to learn from the internal workings of what we deal with, the pressures and the things that the data collection that we have and have to sort through, going back to the Twitter and Amarillo is something that we deal with all the time during these events. They're hectic a lot of times. There's chaos to sort through. So I do think there's a lot to learn, maybe perhaps internally as well. So I think the Weather Service offices will be involved with some of that as well. So, field coordination as well, it would help. And, I just getting the best forecast possible so these guys can set up where they need to and things like that, all part of it as well. So.
And I want to add, the Weather Service has been really involved in the planning of Vortex Southeast from the start, including Kevin, and now in this latest workshop, I think we had a dozen Weather Service people, and that's really been, that was probably one of the key parts of this workshop, is that the Weather Service people could kind of talk between the social sciences and the atmospheric scientists and keep it real in terms of what the problems are, both in terms of our understanding of the atmosphere and in the way we communicate to the end user. So we intend to keep that Weather Service involvement and actually have the Weather Service involved in the transfer of any new knowledge from the researchers to the operations.
So, Eric, over 20 plus years, the cost of a project like this has probably escalated. So can you talk about what the cost has gone from Vortex 1 to 2 to what you expect the cost of this one to be?
Well, that's a good question. I don't remember the first one exactly. I think it may have been in the 3 to 4 million range. I believe the Vortex 2 was north of 10 million, maybe up around 12. But Well, someone's probably going to shoot me for saying that because it's probably way off. But so I think it went up maybe 3 or 4 times between the first vortex and the second one. The funding that Congress provided to Vortex Southeast was $5.4 million for the calendar year we're in right now, and that's money that was used for planning and will be used for next spring's research. And apparently there's a talk to have about that same level of funding again for fiscal year 2017, which would be fantastic because we have a real full platter of research ideas that are pretty important for the Southeast.
So how long will it take to swim through all that data? How long did it take after 1 and 2, and how long do you anticipate as the data continues to increase exponentially that it'll take to sort it all out?
That's a good question. I think it took probably 5 or 6 years before we'd really utilized the first Vortex data well, and probably about the same for the Vortex 2. Something that's a little different about Vortex Southeast, the way it's going now, is that we hope to have the planning done on kind of a continual basis. So the idea is that at least once a year, actually continually in a virtual workshop, we're going to keep refining the research ideas, have a discussion between all the involved scientists, but at least once a year review the plans and decide, is there new technology available? Are there new ideas out there being talked about? And so we can continually update the science ideas and keep pursuing the things that are most important at the current time. I think it's kind of sort of the issue that you just brought up is you have these big experiments and then you spend years analyzing the data, and by the time you get back around to doing it again, all sorts of other ideas may have crept in, and they probably should have been explored earlier and explored continually. So that's what we're kind of hoping to do in Vortex Southeast.
Yeah, it seems to me, Eric, that the list of ideas that you're going to be exploring is really extremely rich and very varied, and it seems like there must have been some sort of crowdsourcing element in how you put that together. Talk about how you brought the scientists together to gather the information to come up with all the different topics that you're going to study.
It was the biggest fire drill I've ever been involved in. We had the funds appeared, and while I was still happily a science hermit on the western slope of Colorado, and then NSSL hired me to be the program manager in late February, and by mid-March we had a scientific steering committee starting to write down ideas. By mid-April their work was complete, and we had a list of perhaps 20 or 25 science ideas, and then by mid-May we had an announcement for funding on the street, and by mid-June we had the proposals in, and the 1st of July the funds were out. So it was an epic fire drill. But what's been changed, thank goodness, is that now we have the big workshop with 120 scientists, and with a great, big, beautiful set of ideas that came out of that. And now we have this virtual workshop going where those same scientists, and actually anyone in the community, can comment on those scientific ideas and just keep refining them until they really are good enough for funded research. And I think that to me is really important, is to have a scientific idea written down well enough that you can be confident that the new knowledge that comes out of it is reliable new knowledge. So that's sort of what we're trying to accomplish with the virtual workshop.
So Eric, as the program manager, how in the world do you logistically house and feed and take care of all of these researchers? How does that work?
Well, I don't. For this coming spring, it's only 6 funded teams, and through their own individual grants, they're setting up their accommodations. And most of them are going to go with this idea that we're going to, don't laugh, we're actually going to try to predict weather outbreaks. It doesn't have to be tornadoes, but convection in the northern Alabama area 4 or 5 days in advance. Actually, we'd like to predict it 5 or 6 days in advance and say, now we're on a deployment watch, and we will all communicate several times a day. And then no later than 4 days in advance, we'll say, okay, there's going to be storms, we're going to have to go, and we'll all get to northern Alabama as quickly as we can and turn on the instruments. So the accommodations and all those logistics are going to be taken care of by the individual research teams, but we'll be communicating about it every day in real time.
So you heard that. Hotels in North Alabama, time to raise your rates for next spring. So,
Says the guy who owns hotels.
Yeah, right.
But none in Alabama, Nate. That's the only problem.
Well, it's time to
We've
start
got more in
buying.
Oklahoma than we have in Alabama. So
Time to go on a buying spree.
who could? Yeah, it may be time to do that. You're right. So Eric, we brought you here for stories. So I know some of the other guys may have some questions, but tell us a couple of Uncle Eric stories along the way.
Oh, are you serious? Okay, 1982. That was in the previous century, the 19th.
Yeah, as my children say, that was in the 19th century.
So then it was Eric, Uncle Eric. Now I guess it's my new name. I guess then I was a dryland kid. Now I'm Uncle Eric. I was with a team called Sound Chase, which was actually led by a professor and some students from Ole Miss, and their idea was that we're going to take a sound recorder and place it in front of a tornado, and based on the Doppler effect of debris clattering together, and you'll hear the shift of the debris going away versus the debris coming toward, and you can acoustically analyze that and figure out how strong those winds are. Anyway, but I was, I'm game for this mission. Sure, I'll put a recorder in front of a tornado. So we went out, and there's the famous Binger tornadic storm. It produced, I think our team saw a dozen tornadoes, and we had our windshield smashed along with almost everybody else. And we were in the north edge of the town of Binger, and the wall cloud was directly overhead. And of course, being a young, naive chaser, I really hadn't been in the position of being directly under the wall cloud before. I'd always been a ways back and been able to identify things, but the rotation isn't really so obvious, or maybe it wasn't so obvious that I should be looking directly upward. But we were under the wall cloud, and then there's this roaring sound, and I looked to my right, and about 100 yards away, parts of trees are shooting up into the sky. And I said, oh, now I know where we are. And a beautiful tornado formed there on the edge of town and moved out across the open fields, and that was probably about a half-mile wide. And so we took the team. I took the team. I shouldn't say we. I'm trying to get out of something here. So I took the team around in front of this Binger tornado, and we stopped, and it was coming at us, and it was obviously violent, but slowly getting larger and larger. And so we put down the sound recorder, and I said, well, it's probably close enough. And so we jumped in the van and started to leave. But being young and naive, I was young once, the tornado kind of gets very large very fast when it's on your doorstep. And the gust front came around the tornado and slammed into the side of the van, and so the van was kind of sliding sideways across the highway, and we could maybe muster 20 miles an hour without losing control of the van as we tried to escape this tornado. And I turned around and looked out the rear window, and all I could see was debris from one side of the sky to the other. So that was pretty exciting, especially back in 1982. Now the chasers like to kind of do that routinely, but went back the next day and saw livestock hanging in the cottonwood trees where we really had been, and the brick home where we had been parked was nowhere to be seen. So that was an interesting event. There's an Uncle Eric story.
Mm-hmm.
And I don't think the sound recording told anyone anything.
Did you actually recover the equipment?
Yeah.
And Rick, you mentioned something in chat about that. Why don't you share that?
Yeah, I can't remember. Was it the Nova special? I mean, there's some video. It looks like black and white video, but there's some video of that. Do you know what I'm talking about, Eric?
Yeah, I do.
Get the sound package or something. I could use. I used to be able to recite it by heart, probably.
Yeah.
But
that's another Uncle Eric story. That was the same vehicle, and that was a tornado over by Tecumseh. And actually, we had a little bit better situational awareness because the guys on the radio had told us that the Doppler, pretty much experimental at that time, was seeing rotation, and we were heading right toward it. So, and I could see the rain curtains kind of wrapping around the southwest part of the storm and crossing the highway. So I told the driver, who was my brother Neil, I told him, slow down, because this would be where we would drive right into the tornado, and be very, very careful. I think it's the quote. Yeah. And anyway, so yeah, we do go through the rain curtains, and I look to the left. Let's see. Yeah, so that's the opposite side. Binger, I look to the right. This one, I look to the left. And it looked like a flock of birds. And I think I muttered to my brother, there's birds. And then we looked a little closer, and in fact, it was just a flock of debris coming up right to the left of the highway.
Wow.
He did stop in time, and then you see on the video, you see this ghostly white vortex, maybe 3 meters wide at the bottom. No, it wasn't even that wide. It's probably about 2 meters wide, crossing the highway and going off through the field. And it was very cool.
Yeah.
I think my old stories are a lot better Uncle Eric stories, and the recent ones are just sitting back in a command vehicle and telling the undergraduates to go in and do the dangerous stuff.
Yeah, that's the benefits of wisdom and age, I guess. So, talk about the Vortex 1 and that famous tornado that was caught from start to finish and how important it was to the success of the project.
Yeah, that was a great tornado. Dimmitt, Texas, I think it was the 2nd of June of 95. 95. We had seen a fantastic tornado up at Friona, which is northwest, I think it's northwest of Dimmitt as the crow flies, and that was just a big tornado and not real satisfying for the chase teams because the inflow to that storm was so full of dust that the visibility was about 100 yards. And so the only teams that really got to see that tornado were the ones that were sort of north, northwest, northeast of the tornado, which is not a really good place to be. But so we didn't deploy real well on that tornado up at Friona. It's too bad. In fact, that tornado probably needs to be studied more because there are some good data sets. But anyway, so we all broke off. We had some information that a new storm was forming to our southwest, and that might be the next good candidate. So we made the decision to just get down to the Dimmitt area as quickly as we could. And in fact, we got there. The first teams were there about 15 or 20 minutes before the tornado, and then the rest kind of filled in. And we could see that funnel forming from afar, and we actually could do the digits, read the digits on the radio thing, and triangulate, and knew just about to the nearest half mile where the funnel cloud was forming, and got some really interesting data there. I think that, as I will say, as Uncle Eric, the field coordinator, it's hard to be really satisfied with any of these deployments because, again, it's back to that ideal deployment and getting that perfect data set, which is never going to happen. But what really seems to happen, at least in Vortex, the first Vortex, was that a big picturesque tornado forms, and everybody, all my mobile mesonet teams are supposed to be driving around the tornado and measuring gradients and temperature and humidity and finding the fronts and stuff, pull off to the shoulder, hit the brakes, and get out with their cameras and start taking pictures. So the data sets are never quite what you hope, and that's a conspiracy of human nature and roads and the atmosphere and a lot of different things. So it was a fabulous event. We caught it from end to finish. In fact, beginning to end. In fact, that tornado actually peeled up the asphalt off of the state highway east of Dimmitt, which happens a few times, and as far as I can tell, only happens with some of the more intense tornadoes.
Yeah, I've seen a video of that. Yeah, one last question for me, Eric. Will there be an effort to put some information, maybe a log, real time on the internet so that we can follow the project?
Well, I think there ought to be. I'll put that on my to-do list. I think it'd be a great idea.
Good.
I know that was one of the cool things with, I don't know if it was Vortex or, I remember around the May 99 tornado, you guys had, you would put your forecast up online, or I think that was a Vortex thing. But yeah, something like that would be really great.
That'd be great. Maybe we could actually get some real-time data up there so people could follow the deployments and see what the atmosphere is doing too. That'd be fun.
Yeah, that's exactly what I was thinking.
Yeah.
Great idea.
Yeah, well, maybe we'll embed Dr. John Scala and send him out with you guys. So if you save a place in one of the vans for him.
Well, I think out there with a handheld anemometer, right?
I'm not grad student anymore, Eric.
If there are any research aircraft, sign me up.
There you go. Yeah. Talk about the role of research aircraft and the other ones and how that folds into this one.
Yeah, this spring in 2016 there will be a octocopter UAV flown by the NOAA's ARL, and that will be to profile the boundary layer and measure the temperature, humidity, pressure through the very lowest, I think the lowest 400 feet is what they have permission to do. But in 2017 we hope to really expand on that. I really can't tell you what the plan is for 17 because we don't have a plan yet. Right now we're just gathering the research ideas and putting them into a map of what should happen sequentially. But I have a feeling from what I've seen so far is that in 17 we're going to really attack this idea of how do you measure winds well in complex terrain. And I think one of the components of that is going to be having NOAA's airborne hurricane hunter plane with their Doppler radar, and perhaps other aircraft equipped with airborne Doppler radar, so we can be looking down into the terrain as well as seeing it from the mobile Doppler radars. And
that's a good point too, because I think the UAVs are, you know, the popularity they're getting, those are going to become a major research player over the next decade, I think. So you can kind of see the trends going toward those UAVs are becoming very inexpensive, and to put instrumentation, I mean, now you can put your cell phone on them and basically measure anything you want, so including taking pictures. So I think that's going to be a big research tool for us coming in the coming decade.
And they're relatively inexpensive. You're not risking somebody's life in it as you would in say a helicopter or traditional manned aircraft. The thing about that worries me though is, of course, the FAA just came out today and formalized their requirement that drone owners will have to register their drones. It's a one-time thing. Well, it's a renewed thing, but it's very inexpensive. It'll be free for the first 30 days that they do it here. But you've already got some folks out there experimenting, pushing the boundaries of this. I've seen video of a drone flying through a cloud deck well beyond the 400 feet that the FAA allows. And I'm worried that somebody's going to do that and they're going to get their hands slapped, or worse, that it won't be the FAA, but it might be an employer that comes down, perhaps overreaching, overreacting, as employers sometimes do. And I'd hope that anybody who's flying these things and doing weather-related stuff, is really taken care. And that's just me saying this as a weather geek who really wants this technology to be exploited, because I think it's really, really cool, the kinds of things that we'll be able to do and the things that we'll be able to see, and especially if you maybe later in 16 or in 17, if the UAV operators do get some sort of permission to fly higher than 400 feet AGL. I think that really does open up some really interesting possibilities. But also, as a guy who flies small aircraft who might have to share airspace with some of these things flying above 400 feet, that's my keister in an airplane, and I don't want somebody who's flying and doesn't know what they're doing or isn't respecting the rules of the airspace endangering my life. And I know that nobody intends to do that, certainly, but it's the unintentional stuff that can get us all in trouble.
Yeah, there's no doubt. That I think most of the people who are doing things like you mentioned, like flying into the clouds, are giving themselves exemptions from the law, which never really works in the eyes of the law. You have to have eyesight on that aircraft. You can't fly it over other people's land without their permission. At the present time, you have to be a trained pilot, even having a physical, to get permission from the FAA to fly. In NOAA and in the universities, we're playing by the rules, and it's been a long, slow process, I have to say, to get permission to even make the basic weather observations. But it is changing, and I think there will be a lot of progress over the next few years.
Yeah. Well, one good thing too about them.
Well,
I was going to say one good thing too about them is that you can, unlike aerial craft, you can pinpoint exactly where you want these things to go, exactly how high, and so there's a lot of programming behind it. And like you said, Nate, I think those things are an accident waiting to happen, and eventually we're going to have the accident. And there's pilot reports of people too close to airfields, and eventually there's going to be a disaster, and they're going to have to come down hard on it. So maybe we can get, and I think our people hopefully are extremely careful, and I think we can maybe get a few good years out of them in the subsequent years of the vortex southeast. Not to make that a big point, but I think that's just going to be something that we see in the next decade or two being important.
Okay.
Is a cost-effective way to research, that's for sure.
Yeah, it's certainly cool, and I'm really excited to see kind of some of the things that can and will be done with it, both with Vortex and with local folks. And we've got a number of local folks here in the Triangle who are flying, taking aerial photography and things like that. And the shots are fantastic. there's no question that we can see things and do things that are really really cool. But I don't want somebody, like you said, Eric, giving themselves an exemption, ruining it for everybody. Because that's what'll happen, Kevin. Just like you said, that's exactly what'll happen. It won't be a measured reaction. Oh well, that was a one-time thing, and we can educate. The tendency is to overreact on that sort of a thing, and I'd hate for that to happen because that's going to shut down a lot of doors and a lot of opportunities for a lot of well-meaning and well-intended folks.
Well, I'll tell you, and just one more last comment about it. Sorry, Bill, but it'll probably be the hot ticket item for Christmas this year. I'm sure for a lot of people, and it's going to be hard to shut that lid. So if they're going to get a handle on it, it's almost like taking away everybody's favorite toy. And good luck with that now. It's almost out. It's out of control. So as soon as I saw the one for $300 or $400 that you can put your iPhone in, I was like, wait a minute, maybe I can actually do this now. So it's just everybody wants to try it out at least. So anyway, go ahead, Bill. I'm sorry.
Well, Kevin, I wanted to ask you, is anytime we have you on the show, we, of course, have admired everything you've done in the last 4 years or so at BMX about, warnings and science behind the warnings. So talk about any progress you guys have made, any successes you want to share, any challenges you've got with your staff going forward.
Yeah, even though 2015's been quiet, it's been our best year, and I'm really happy with the progress we're making. And I thought about this today. I was like, okay, can I just sum it up really quickly? And that is, we putting all the numbers aside and all the work that we've done, it comes down to one thing for us, and that is, our job and our mission is to protect life and property, right? So that's what we're mandated to do. And without complicating the process, and it is a complicated process, I've gotten to where I'm just saying to our folks, hey, does people need to take action from this storm? If the answer is yes, make it personal for you. If the answer is yes, then let's issue the warning. If the answer is no, then let's maybe stand back and wait a scan or two and see what happens. Maybe wait on a report. So it really comes down to our mission and getting back to what we're mandated to do, and that is to protect life and property. Because I think a lot of times people get wrapped up in the numbers, and the false alarm rates are too high, and the PODs are too low, and you can really get wrapped around the axle with a lot of the numbers. But let's just forget the numbers for a second, and let's get back to our mission. And do you think that somebody needs to take action to protect their life or property from that particular storm? If the answer is yes, if your mom was standing in downstream of that storm, does she need to take action to protect her life and property? And if the answer is yes, let's give people the warning that they need and the lead time that they need. So it's really boiled down to something that simple without getting too wrapped around the numbers. But otherwise, I've been ecstatic to where the research we've done and the challenges that we've met along the way. So.
Kevin, I'll just jump in real quick. I admire that philosophy, and I know that we've been talking to your office about this because we've been having some discussions recently, and it just really gets down to the point of what are we issuing a warning for? What's the point of a warning? And that's to prompt action. Do we need people to take action? Then that's it's kind of a non-hardcore science way to look at it, but I think it's an important thing to step back and think of that. So I admire that philosophy, and we're thinking along the same lines.
Cool.
Yeah, it really makes it simple. Yeah, go ahead, Nate. I'm sorry.
I was just going to say we need to go ahead and wrap up here. It's 11 o'clock, and we still have picks of the weeks to do. Picks of the week, singular week. This is the part of the show where we go around the digital mahogany table and share something weather-related. Can be anything from a website to a new app, book, or in my case, my pick of the week is a job announcement. About a dozen entry-level meteorologist intern positions with the National Weather Service will get posted. The posting goes effective tomorrow, runs through the 30th of December, so you've only got about 2 weeks to turn that around. If your dream is to work in the National Weather Service, this could be your time, and I know a lot of folks graduating here in December. So I want to say that the last time there was a job opening, Rick, at your office, you had something like 300 people that got referred down. So to say that it's competitive is a bit of an understatement.
Yeah, it's like that even at offices you wouldn't think it would be like that at. So yeah, it's extremely competitive, and I'll I will say that there also is a big a bid out for journeyman forecasters, which is what you do after you're a meteorologist intern. So at some point there'll be another wave of intern openings, but this is a good time to throw your hat in the ring.
And it's one of those. I had a conversation on my Facebook page with a couple of folks. It's a lot like TV. If you got to bid for all of them, and get your foot in the door wherever you can. And I got to tell you, the list of places you could wind up is a pretty solid list of offices with good reputations, good management. So if you're going to bid, if you've ever thought about it, you're interested in the Weather Service, now's the time, because there's some really great opportunities out there. Rick, since we're here with you, what's your pick of the week?
Well, I'm a self-professed Star Wars geek, not as much as some people, but more than others. So I had to find a way to combine Star Wars and weather with The Force Awakens coming out this week at a theater near you. Check local listings, whatever. So Marshall Shepard did a thing for Forbes last week, I think it was, kind of tying Star Wars and weather together. So how appropriate. So that's my pick of the week.
All right. Thank you, sir. Bill Murray, pick of the week.
Yeah, first a couple of guests that are coming up. Next week, Andrew Oldacre. Greg Carbon on the 22nd. That show now that would have been on the 28th, guys, is on the 22nd. Carol Fowler, the lady who says James Spann tweets too much, on January 4th. Joe Bastardi on a Tuesday night show on January 12th after Alabama beats Oklahoma in the national championship game. Sorry about that. The 18th, in-flight cockpit weather. Niall Robinson from the UK met on my birthday on January 25th. And the CCAPS folks, Keith Blackwell and the folks at the University of South Alabama, their big conference coming up February the 15th. And my pick of the week is the fabulous depiction of the RAP data from Brian McNulty. I've got that as my pick of the week, Nate. Thank you.
All right, thank you. Dr. John Scala, pick of the week, sir. Have to click the old mute button there. There we go.
All right, very good. Yeah, my pick of the week is the California Weather Blog. This is some interesting posts made by a graduate student at Stanford University talking about the current El Nino and the potential for storms in California. Really interesting.
Good stuff. Kevin Laws, pick of the week, sir. Not a kick. This is not soccer. Pick of the week.
Shameless plug for us, but we were chosen to be one of the test offices for Periscope, so we will start doing that. So I would encourage anyone to follow us on Twitter, because over the next few weeks to few months, we will start doing live broadcasts of maybe some interesting things around, maybe a storm spotter class, maybe an upper air launch, and any time ahead of any severe or any kind of winter weather. We'll probably go live with Periscope to answer people's questions live. So we're going to be one of the test bed offices for that. So I would encourage anyone to follow us on Twitter.
Hey, Kevin, can you talk about your little chief meteorologist powwow? I think you guys used it for the first time this weekend. Anything that came out of that?
Say that again, Bill. I'm sorry, you broke up a little bit.
You and James and the chief meteorologists in Birmingham, at the big four TV stations, sort of put your heads together in advance of this event. I think that was the first time you got to do that. Talk about the outcome of that.
We did that on Friday. The goal, again, Bill, just like we talked about with the warning program, is to send out a consistent message and a life-saving message. And I think I got to commend all of our chief Mets and all of our TV stations in our markets that we've come together to try to, there's always a competitive edge and that, but I think our folks really understand, especially after the events that we've been through, that we want to get all on board with the same color scales and the same message, because our job is to protect life, and I think that's very unique. You probably wouldn't see that in a lot of places, and so I commend our TV folks for joining forces with us to help us all complete our mission. So it was good, and this event turned out to be a non-event, but it was a good run through, and we were able to talk about a non-event that was about to incur, and I think that tamped down some of the hype that may have been early on, and so we were able to get out that message, and I think that was heard loud and clear, so it was great.
Very cool. Yeah. Eric, pick of the week, sir.
Hey, it's not fair. I didn't know I had to have one.
Yes, you did. I told you about it. What are you talking about, Eric?
You told me I could cut out early.
Oh, that was true. Yeah, we kind of reversed the show order there on you. Sorry, Eric.
You guys help me out and share a pick with me, and I'll give you a seat in one of the Vortex Southeast team mobiles.
Oh, well, in that case, there was an article. Actually, I'm totally taking you up on this. There was an article put out by WDT on their blog, also linking the weather and Star Wars. It was put out by their director of meteorological outreach. Speaking of jobs that I wouldn't mind having, pretty cool stuff there. So I'll have my travel agent be in touch with you, Eric, to make arrangements for that. And I saw Kevin Selly. He came and went. So, Kevin, are you there? Hi. Never mind.
We'll get you one of those $250 hotel rooms, Nate.
That's right.
At the Sleep Inn in Madison.
All right, Eric, how can folks get a hold of you if they're interested in learning more about Vortex or hearing more Uncle Eric stories?
Criminals. Where did that come from? I guess maybe the best way is this account that I set up just for this is Vortex Southeast, Vortex SE at gmail.com. And people ought to look at there's a nice Vortex Southeast webpage that the NSSL, that's linked onto the NSSL homepage too for a lot more information.
It's good stuff. Kevin Laws, how can folks get a hold of you?
Yep. Well, best way is through our website, and you can always hit the email down at the bottom of the website to contact anybody at the office, or that's usually the best way. And get a lot of good questions on there and a lot of things about what we're doing, and so that's always a good way to hit us. So we're always there 24/7, no matter what, so we'll be watching.
All right. This has been WeatherBrains. It's the All About the Weather netcast. We normally record it on Monday nights at 8:30 Central, 9:30 Eastern Time, but we'll have a couple of scheduling deviations here in the next couple of weeks due to the holidays, and some other folks who've got a couple of Tuesday shows coming up, so please keep an eye on the WeatherBrains Twitter account, WeatherBrains Facebook page, or if you're just automatically getting the podcast downloaded into your device, just look occasionally for an extra episode you weren't expecting. It's cool like that, how it works. Let's see, what else? You can find us on Facebook, Twitter, Google+. Just look for WeatherBrains. That's probably where we are. And, of course, we love getting the comments on iTunes, Stitcher, everything else. Let us know how you think we're doing, good, bad, or ugly. We like the bad comments, too. Every now and again, we need to get taken to task. Doesn't happen often, but it does happen. So if you've got a comment, just let us know. Good, bad, or ugly. I promise you won't hurt our feelings. Until next time, I am not James Spann. Good night and God bless.
Great job closing the show down there, Nate.
Thank you much. Thank you, guys. Eric?
Fantastic show. Thank you, Kevin. Thank you, Eric.
Thanks, everyone. That was good.
Yes. Thanks, Eric. Good
See
to
you in the
again.
spring.
Yep.
All right.
Y'all be safe. Happy holidays. Take care.
Take care. Merry Christmas.
Thanks.
Ooh. Wow. I think we've never had a show to go this long. Wow. Looks like they wrapped up at 10:09 Central. It's 10:49. So I'm 40 minutes after the end of the show. Wow. But creepily enough, there are people watching. I can't wait to hear this one. Eric is a very, very well-known, well-regarded, longtime severe weather researcher. So it was great having him on the show tonight. And Kevin Laws is, of course, local to us. He's the SOO, the Science Operations Officer at the National Weather Service in Birmingham. And Kevin is a great guy, and I have learned so much about from him about the warning process and basic science, and he's a great guy. So that was a good show. So it is late. I got to go take a nap. I got to get up really early again tomorrow. It's a very busy time of the year for us. And we're concerning the year ender with Greg Carbon of the Storm Prediction Center. We always do the top events of the year. It's scheduled for Monday, December 28th. I will be off that week, so we're see if we can squeeze it in maybe the 22nd or 23rd, Tuesday or Wednesday of next week. So don't know if the guys talked about that, but we'll see if we can make that happen. So thank you guys for watching. Y'all have a great week, and we'll see you next Monday night. Bye.